Somewhere out there, there might be a version of you who didn't click this video. Honestly, lucky them, but also, is that actually true? Let's find out if the multiverse is real science or just physicists coping. Here's the real answer up front. Nobody has ever seen another universe, but several completely separate, serious branches of physics, done by people who are not high, keep spitting out the same weird suggestion. Our universe might not be the only one. Not one theory. At least four unrelated ones. Let's meet the suspects. First, quick reset. Universe used to just mean everything, all matter, energy, space, time. So saying other universes sounds like a contradiction, like other everythings. The fix. Physicists redefined our universe as the observable patch of a much bigger, possibly infinite structure. Multiverse just means our patch isn't the whole structure. Suspect number one comes from the Big Bang itself. The leading model of the Bang's first fraction of a second is called inflation. Space expanding faster than light for a blink, then settling down. Problem is, when scientists worked out the math carefully, they found inflation might not stop everywhere at once. Picture space like a pot of boiling water. Some patches cool down and stop inflating. That becomes a universe like ours. Other patches keep expanding forever, spawning new bubble universes inside them, endlessly. That's eternal inflation. Each bubble can end up with different physical constants, like a cosmic slot machine, landing on a different combo every spin. Why haven't we found a bubble? Because the space between them is still inflating, stretching faster than light. So light from another bubble can literally never reach us. It's not that they're far. It's that far keeps growing faster than anything can cross it. Convenient or suspicious, depending who you ask. Suspect 2 comes from quantum mechanics, and it's the one people usually mean by the multiverse. It starts with a genuinely creepy fact. Tiny particles behave like they're doing multiple things at once, until you measure them, and then they pick one outcome. The classic thought experiment. A cat in a sealed box. Its fate tied to a random quantum event. Until you open the box, the math says the cat is in a blend of alive and dead. Obviously, when you open it, you just see one cat, alive or dead. The question physicists argued about for a century: what happened to the other possibility? One answer, called many worlds, says nothing was ever lost. Both outcomes happen. The universe just splits into two branches, one where the cat lives, one where it doesn't, and a copy of you ends up in each branch. Each copy fully convinced their outcome was the only one. Every quantum event ever branches reality again. And quantum events are happening constantly, everywhere, all the time. So under many worlds, you're not living one life. You're the sum of an almost incomprehensible number of branching yous, all diverging every fraction of a second, none of them aware of the others. It's less sci-fi multiverse and more math refused to pick a lane. You've probably actually heard the word multiverse before, just not from a physicist. Spider-Man, No Way Home, Doctor Strange in the Multiverse of Madness, Loki, everything everywhere all at once. Hollywood loves parallel universes because they're a free excuse for a crossover, and it turns out they're borrowing straight from the many worlds idea we just covered. Swap timelines, meet alternate yous, no rules broken. The science is way messier than the movies make it look. But the core idea, and you're not the only version of you, didn't start in a writer's room. Weirdly, many worlds appeals to a lot of physicists because it's the option that adds the least new stuff. It just says, take the equations of quantum mechanics literally, don't bolt on a mysterious collapse step, and the branching falls out for free. Whether that's beautiful or insane depends on your tolerance for infinite U's. Suspect 3 comes from string theory, the attempt to describe every particle as a tiny vibrating string. String theory only works if there are extra hidden dimensions curled up impossibly small. But here's the catch. There are an absurd number of ways those extra dimensions can be curled up. Estimates put the number of possible configurations around 10 to the 500. A number so big, it makes the observable universe's atom count look like pocket change. Each configuration is a valley with its own values for gravity, particle masses, everything. Physicists call this the string landscape. If it's real, and if other valleys are physically realized somewhere, that's trillions of possible universes. This actually annoys a lot of physicists, because a theory that can produce basically any set of physical laws stops being useful for predicting our laws. Critics call it borderline untestable. Defenders say it might explain something huge. Why our universe's constants look so suspiciously fine-tuned for us to exist? Small tweaks to constants, like gravity's strength or the electron's mass, would make stars, atoms, or chemistry impossible. That's the fine-tuning problem. One explanation: a designer set the dials. Another, less mystical explanation: there are countless universes with every possible dial setting. And we obviously live in one of the rare ones where the dials allow observers to exist to ask the question. That's called the anthropic principle. It's less magical than it sounds. It's just survivorship bias, cosmic scale. If only some universes can support observers, then every observer who ever wonders about this will find themselves in one of those universes, no matter how rare they are. It doesn't prove multiple universes exist, but it's a tidy explanation if they do. The fourth suspect is the wildest one. What if every mathematically consistent structure physically exists as a universe? Not describes a universe, is one. Under this idea, our universe isn't made of stuff that follows math. It literally is a math structure, and so is every other one that could logically exist. Most physicists treat this one as a fascinating thought experiment, rather than a working theory. It's nearly impossible to test, maybe impossible in principle. But it's worth knowing it exists, because it shows the multiverse conversation ranges from solid math with weird implications to philosophy wearing a physics coat. So can any of this be tested? A little. If our universe's inflating bubble ever collided with a neighboring bubble billions of years ago, it might have left a faint circular bruise in the leftover heat of the Big Bang, the cosmic microwave background. Scientists have actually looked. So far, no confirmed bruises. Not proof it's false, just proof it's still just a hypothesis. That's the honest state of things. 4 separate lines of legitimate physics: inflation, quantum mechanics, string theory, and mathematical philosophy, independently stumble into the same weird corner. Maybe there's more than one universe. None of them have been proven. None of them have been ruled out either. Quick recap. Eternal inflation says bubble universes keep popping up forever, each sealed off by expanding space. Many worlds says every quantum event splits reality, and you're branching constantly. The string landscape says there could be 10 to the 500 possible universes with different physics. And the mathematical universe hypothesis says maybe math itself just is reality all the way down. So, could the multiverse really exist? The honest answer: maybe. And some very smart people think probably. But nobody can currently prove it either way. The moral here isn't reality is infinite copies of you. It's that our best theories, taken seriously and pushed to their logical edges, keep leading somewhere stranger than fiction. That's not a flaw in physics. That's the job working correctly. Anyway, statistically, somewhere out there, a version of you already turned this video off 10 minutes ago. Be like that guy. Good night.